Hello, and welcome to today's lesson on topics under the standard 2.2a. And then we're also covering questions under the study island lesson Symbolize system. So in today's lesson, we're basically translating word problems into equations. So if you need to brush up on some of that vocabulary, I recommend that you go to my Algebra 1 video that's titled Standard Point 1.1a, Symbolize Problem Solutions, and I go over a lot of the vocabulary you're going to need for this lesson here today. And then also, just remember our study tips. Make sure that you're taking notes because those are going to really help you to study from and to refer back to when you're trying these questions on your own. And if I go too fast, just pause and rewind. There's no harm in that. And then also, remember, you can pause at the beginning of a question, work that problem out, see what you think the answer is, and that way you can get a good gauge on how well you're learning this or if you need more practice. So I'm so glad that you're here, and let's go ahead and look at some problems. This problem says Johnny and Samantha are going to a water park and an amusement park. They can only spend a total of 12 hours at the two parks combined. Concessions cost $4 at the water park and cost $3.70 at the amusement park. They can only buy one concession an hour and can only spend a total of $46.80 on food and drinks. Which system of inequalities can be used to determine the number of hours Johnny and Samantha can spend at the water park? We're going to use W for that, and the amusement park, they're going to use A. So, you know that the total hours has to be 12 or less. So if we add these two, the water park hours and the amusement park hours together, that's going to have to be less than or equal to 12. So that one's fairly easy. So right away, I can eliminate B and D. Okay, so now I'm looking, and you can get some hints from the problems, like you can see how they're going to have to be set up. And here they're putting the 370 with the W, and here they put the 370 with the A. Well, 370 is how much they cost at the amusement park, and so that means it's going to be with the A, not the W. So right away I can see my answer is going to be C, without actually having to set up the equation. But if you want to know how that works, it's the $4, you spend $4 for every hour you're at the water park. So that's why the $4 times how many hours you're at the water park. And you spend $3.70 for each hour you're at the amusement park. So you take that times your hours at the amusement park. And they have $46.80 to spend. So they can spend that much, or they could spend less than that, so that's going to be less than or equal to. And that's where they came up with that equation. Okay, this question reads, income I is equal to base pay B plus commission C. Commission is equal to the number of sales S times the amount earned from each sale E. So then we have to figure out which system here represents this situation. So this one is just simply translating the sentences. So it says income I is equal to base pay, which we're using B for, plus commission, which we're using C for. And then commission is equal to the number of sales, which we're using S for, times the amount earned from each sale, which we're using E for. So then the answer that has those two equations is letter B. This problem says Michael stocked the break room with snacks. She stocked as many bags of chips, which we're going to use C for, as bags of pretzels, P, and granola bars, G, combined. She stocked as many cans of soda as bags of chips and bottles of juice combined. Which system equation models this situation? So here, once again, we're just going to translate the sentences. So here we know that the bags of chips is the same as the bags of pretzels and granola bars combined. So that's going to be C equals P plus G. And then the cans of soda is the same as the bags and chips and juice combined. So we're going to take C plus J. So the answer that has those two equations is letter C. Okay, this problem reads, Betsy is thinking of two numbers. The first number is 4 more than twice the second number, and the sum of the two numbers is 17, which the system of equations can be used to determine the first number, x, and the second number, y. So we're just going to translate these, but every time we see first number, we're going to write an x, and every time we see the word second number, we're going to write a y. So here, this first sentence, the first number, so we're going to write an x, is, that means equals, 4 more than, so it's going to be 4 plus, twice the second number, so it's 2 times the second number, or 2y. The second sentence then is the sum of the two numbers is 17. So sum means you're going to add the two numbers. So x plus y is the same as equals and 17. So now the problem, the answer that has those two is C. This problem reads, Steve is a waiter. Last night he earned at least $98 total hour wages and tips. He earned at least 3 times as much in tips as he did hourly wages. He earned at least $18 in hourly wages and at least $80 in tips. Which system of inequalities models this situation where H is hourly wage and T is tips? And so you look, we have to get 4 inequalities from this equation. So take it sentence by sentence. Okay, the first one says $98 in total hourly wages and tips. So that means when we add the hourly wages plus the tips, it has to be at least $98. So it could be $98 or it could be more, so we're going to use the greater than and equal to symbol. Okay, the next sentence says is he earned at least 3 times as much in tips as he did in hourly wages. So the tips is going to be the bigger number, and at least means they could be equal, and the tips was 3 times bigger. So that means if you take the 3 times the hourly wages, tips is either the same as that or bigger, is what that sentence is saying. And then he earned at least $18 in hourly wages. So his hourly wages was bigger than or equal to $18. And then the same but $80 in tips was at least, so that's bigger than or equal to 80. And so those are the 4 inequalities, and the answer that has those 4 exactly the same is B. Okay, this equation says Sam and Freddie each left for school for a trip over spring break in their own cars. Sam began the second day 280 miles from the school and drove 59 miles per hour. Freddie left the second day 230 miles from the school and drove 49 miles per hour. Let S represent Sam's distance from the school at the end of the second day, and F represent Freddie's distance from the school at the end of the second day, and X represent the number of hours they both traveled. So this time they give us the equations, and they want to know what's true about them. So if you look here, they want to know what's true about their slopes. Remember, slope is the number in front of X. So here, the equation, the S equals equation has a slope of 59, and Freddie's equation has a slope of 49. So they're both positive numbers, but they're not the same, so that means D is going to be my answer. So this problem looked pretty big and confusing, but really all you had to know was which numbers were the slope. Here it says the school dance team is attending a rehearsal for the city ballet. There's a total of 24 people attending. Student tickets cost $2 and adult tickets cost $10. Let X represent the number of students attending and Y represent the number of adults attending. Which statement is true about the graphs of the equations? So here they give us all this information, but then they give us the equations. So we just know what these equations represent. And here they want to know, are these graphs going to intersect? Well, each of these graphs, the x is just a plain x, so we know that they're linear graphs. And so that means they can either be parallel, they can be the same line, or they can cross at one place. So that means they're never going to intersect twice, so B right away is out. So in order to see if they're the same line or not, we need to put them in slope-intercept form, which means we need to solve each of them for y. So my first equation is x plus y equals 24. To solve that for y, I just have to subtract x from both sides. These x's cancel, and I'm left with y equals 24 minus x. And then I have to go ahead and solve my second equation also. I'm just going to leave off the decimal places, since it's all 0.0 anyways, and the dollar signs, just to make it a bit more simple. And so first thing I'm going to do is subtract 2x from both sides. And that gives me 10y equals 200 minus 2x. And then I'm going to divide both sides by 10, and making sure that I'm dividing every term on the left side by 10. And here the 10s are going to cancel out, and I'm left with y. 200 divided by 10 is 20. And then 2 divided by 10, that's going to simplify down into 1/5 x. So I'm going to look at my slopes here to find out if they're going to intersect once, all the time, same line, or never, they're parallel lines. So my slope here in the first equation is -1. Remember, it's always that number in front of x. And then my slope in my second equation is -1/5. Since these slopes are totally different, that means they're going to be intersecting lines. So they're going to intersect at one place. So that means my answer is C. If they'd have to have the same slope to be parallel lines, and they'd have to have the same slope and the same y-intercept. So the equations would have to be identical for them to be identical lines and intersect infinite number of times. This problem says the home improvement store charges $85 an hour plus a flat fee of $60 for plumbing work. A local plumber charges $115 an hour with no extra fees. H represent the total cost for the home improvement store, P represent the total cost for the local plumber, and X represent the number of hours for work. So they give us all this information so that we understand these equations, and then they want to know what is true about these graphs. So in here, they want to know what's true about their y-intercept. So remember, the y-intercept is the number by itself with no x, the constant number. So here, the y-intercept is $60. And here, it's not written, so you assume it's a +0. So our y-intercept there is 0. So these graphs are going to have different y-intercepts, which is letter A. I am glad that you could join us today, and I hope you learned something new.